Welcome in Corridor. Today we are going to continue our parts for chapter 2. Let's start by superposition of waves. As you see here we have wave, another wave. They are superposed to each other and they are a combination. They are in a state of combination. They are in a state of composition. They are in a state of superposition. They are in a state of superposition. Here, when we have two waves, these two waves are slightly different in frequency. Slightly different in frequency, but they have the same amplitude. If they have the same amplitude and they are slightly different in frequencies, they produce beats. They produce beats. So what's meant by beats? Beats is a superposition. Beats is a superposition of two waves having slightly different in frequencies, and the amplitude is the same. The amplitude is not changed. That's for this definition. What's about the constructive interference and destructive interference? If this end is attached to a sliding ring, this sliding ring, okay, the reflected wave is positive. Why? Because the sliding ring have the ability to move. It moves smoothly around, so it is not fixed. It is not fixed. So if we have a rope and we pass it, we pull it like this one, so when it is reflected, it reflects in the positive direction, so in the same direction as the incident pulse. Yeah, بمعنى if we have crest pulse, it reflects crest pulse. If we have trough pulse, it reflects trough pulse. But when we use a sliding ring, but if we have fixed end, so it can't reflect. So if we crest pulse, it reflects trough pulse, and vice versa. That's for these points. What's about the standing waves? Standing waves or stationary waves. Here in standing waves, I repeat it again, and please you have to concentrate. Look very well. Yes, standing waves. Look here. Yes. In this way. Here a wave, here another wave. These are these two waves between two fixed walls. Okay, here it form node. Here this position, the maximum position, this is called anti-node. So what's meant by node and what's meant by anti-node and what's meant by standing waves? Standing waves means they happens due to the superposition of two identical waves. They having the same amplitude, they having the same frequency, they having the same speed, but they propagate in opposite direction. One of them propagate from left to right and the other propagate from right to left. So they are propagating in the opposite directions. They form standing waves. So standing waves, it arises, it happens, it takes place due to the superposition of two identical waves. These two identical waves having the same amplitude, having the same frequency, having the same speed, but they propagate in opposite directions to form standing waves. So these standing waves, as you see, consist of nodes and antinodes. Node, antinode, antinode. Okay? What's meant by node? Node is the position. Node is the position where the amplitude equals 0, where the amplitude of the vibration is 0. But what's meant by antinode? Antinode here is the position where the amplitude of the vibration is maximum. Is the position where the amplitude of the vibration is maximum. It is the definition of antinode. Okay, what's about the scientific basic of standing waves? Really? The scientific basic of standing waves is the definition of the standing waves. So it arises due to the superposition of two waves having the same frequency, same amplitude, same speed, but they propagate in opposite directions. So the definition and the scientific basic of standing waves are the same. Okay, what's meant by the wavelength of standing waves? If we return to this graph, we see here, if I say the distance between this antinode and this node, this represents just a quarter of wavelength. But from this antinode to this antinode, it's half wavelength. It's half wavelength. But if I say that twice the distance between two successive antinodes, or that twice the distance between two successive nodes, that twice it here, like this, from this point to this point, yes, this is wavelength. From this node to this node, this distance is wavelength. So what is meant by wavelength of a standing wave? Wavelength of a standing wave is twice the distance between two successive nodes or two successive antinodes. What's meant by the wavelength of a standing wave? It is twice the distance between two successive nodes or two successive antinodes. Here it is the meaning of the wavelength of a standing wave. And now with Mel's experiment. And this Mel's experiment, to study the vibration of strings. This experiment to study the vibration of strings. Okay, let's see in the stretched strings, the vibration of the stretched strings. Let's see here, we have here an electric source, this electric source, okay, or vibrating source. This vibrating source connected to a soft string. This soft string whose length from 2 to 3 meters. These soft strings moves or passes over a smooth pulley. This smooth pulley is connected to a weight, this weight or appropriate weight or suitable weight. After that, when this source vibrates, when this vibrating source vibrates, of course a wave train is produced. A wave train is produced. This wave train is produced in the string, which reflects upon in the opposite direction. So it will form here standing waves. So it will form standing waves, as you see here. These standing waves having nodes and antinodes. Okay, that's for number 4. As the weight in the experiment is increased, when the weight is increased, so the tension is increased, so the number of segments also is increased, so the velocity increased, and the frequency for the same wire length is also increased. But, so if the weight in the experiment increased, the tension increased. When the force of tension increased, the velocity increased, and the frequency also the same. But here, for the number of segments, of course, as the number of segments decreases. Okay, the distance between two successive nodes or two successive antinodes is half the wavelength, because the wavelength of a standing wave is twice the distance between two successive nodes or two successive antinodes. So, what is the application of Mel's experiment? The application of Mel's experiment to demonstrate the vibration of stretched strings, the vibration of standing waves in stretched strings, the vibration of standing waves. It is the main use, it is the application for the Mel's experiment, to study the standing waves, to study the vibration of stretched strings, to show the standing waves. That's for the application of Mel's experiment. What's about the vibration of strings? As you see here, this guitar, we have this guitar, and this produces, it produces node and antinode. Here, this guitar, I repeat it again, it is very important. Yes, when you see it, yes, this guitar, the strings vibrates in this way, as you see here. Yes, this is an antinode, and here the node and the other nodes. That's for this vibration. Also, when a string vibrating in this way may produce different tones. So we have fundamental tone, we have also first overtone, second overtone, third overtone, and so on. For the fundamental tone, lowest frequency, first harmonic tone, it consists of one antinode and two notes. So it consists of only one segment. But first overtone or second harmonic tone, it consists of two antinodes and three nodes. So the number of segments is two. Number of segments is 2. But for the second overtone or third harmonic tone, yes, it consists of 3 segments. Finally, third overtone or fourth harmonic tone, it consists of 4 segments. So if you want to calculate the length of the string equals n, which is the number of segments, times lambda over 2. But in general, lambda equals 2L divided n. 2L, which L means the length of the string, but n here the number of segments. Finally, for this part, number of segments equals number of antinodes or number of nodes minus 1. At the end, I hope to understood the vibration of strings, Mel's experiment to study the standing waves. I hope to join us in the next part. Thank you and goodbye.